Okay, we are now recording, so now let me get screen share set up. From 1.4, we should finish finally 1.4 today. And I've got to move this taskbar out of my way. It's just smack on covering part of the slide. So let's get that moved. We'll start this one from current slide. And I'll find out if y'all can see this. Okay, can you see that okay? It says example 4, even though we finished example 4 well back. The next slide here is this one. This is where we're beginning today. All right, before we get going, any other questions, issues, concerns, problems, anything you want to bring up before we get going with today's class? Anything? All right, now I want someone to remind me, what in the world do we mean by the domain of a function? Anybody? Domain is any of your possible inputs into the function. Now, the most popular way of expressing a function is this: y is equal to f of x. Braxton, were you going to say something? I saw your light come on. Maybe not. Okay. Remember, we express a function y is equal to f of x. That's the most popular way of doing it. The y is the output. Okay, that's what you get out of the function. The x is what you put into the function. All the possible values for that input. It doesn't have to be x. It could be anything. But that's what we call the domain. Okay, so that's just a little bit of a review. The domain of a function. Okay, I'm going to move you students. Braxton, you're in the way, so I'm going to scoot you. I don't know where's best. Yeah, I guess to the right as far as I can. That'll do it. Okay, the domain of a function can be described explicitly, or it can be implied by the expression used to define the function. Now, up till now we've been using mostly explicit domains. Remember when we had the times of day and the temperature? The explicit domain was, I believe it was times 1, 2, 3, 4, 5, and 6, or something like that. Those were the hours of the day explicitly described. That was the explicit domain. Those 5, 6 hours, whatever it was that we were looking at the temperature. However, when we're using functions, the implied domain of a function, you always start with this. We assume all real numbers, unless there's some place where the expression is not defined. So it's all real numbers for which the expression is defined. So we always start thinking all real numbers unless we have to exclude some. So here's a function here. F of x is equal to 1 over x squared minus 4. Now, what's somewhat problematic about that expression? F of x equal x squared minus 4. Anything ring your bell? Okay. I'm going to tell you. You have a variable in the denominator. And variables in the denominator, that's okay. It's legal for them to be there. That's okay. Except for this. Remember what denominators can never be in the real number system?
Negative numbers?
No, they can be negative, but they can't be
or zero.
Zero. All right, they cannot be zero. So basically what you have to say, anytime you have a variable in the denominator, you probably need to do this. Write down that denominator, x squared minus 4, and tell yourself this cannot equal 0. Now that's an inequality, but we treat it the same way we do an equality pretty much. There is one place that we change. And what would you do with a quadratic on the left-hand side? What's the F word? Uh-oh, did I not tell you that? Factor. Can x squared minus 4 be factored? Please say yes. All right, good answer. All right. Now this, if it can be factored, and we don't know for sure it can, but if it could, what would be the only factorization for x? X squared, I mean, x times x. You're absolutely right. Okay? Now, the sign here is negative. So that means one of these has to be plus and one minus. What two numbers multiply to be 4 but add to be 0? 2 and 2. Perfect. Check it. X times x is x squared. Outer would be minus 2x plus 2x. That adds to 0. Minus 4. You got it. Now, if the product of these two entities can't be 0, that means neither one of these entries can be 0. This is where inequality is a little different from equation. Equation, either one of them could be 0. This one, neither could be 0. So this says that x plus 2 cannot equal 0, not or, but and x minus 2 cannot equal 0. And if you solve this inequality, you subtract 2 from both sides, and you get, I'm going to come up here, x, because these two add to 0, x cannot equal negative 2, and here you add 2 to both sides, and this tells you these two add to 0, x cannot equal positive 2. So that's why they say has an implied domain consisting of all real numbers. Here comes Daddy is entering the waiting room. Okay, I don't know who Daddy is, so we're going to have to find out who Daddy is. Hold on just a minute. Let me get my roll sheet. Okay, someone who just came in who's on coming in as Daddy. Who would that be? Who is it? Who just... And who is me? Huh? Ladarius. Okay. Okay. So Daddy Wagner, huh? Okay. All right. Got it. All right. Let me make sure I've got everybody now. Because somebody else may have snuck in. That's 20 students. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Got them all, I guess. Okay. By the way, I've got you in the roll book now. And just this morning, I found out how to put you in Blackboard. Before, every time I tried, if it wasn't the day, I couldn't get you in. But now I found out how to go back and do previous days. So I've got a lot of work to do to get all these attendances in Blackboard. But that's my problem, not yours. So what we're doing is talk about the domain of a function, and anytime we have a function expressed in algebraic form like this one, and you see the variable in the denominator, you need to make sure that denominator can never be 0. And we just did this and found out it is 0 when x, and I forgot, I mismarked here, that's x cannot equal, now the book doesn't do it this way, but it does close, cannot equal negative 2 and cannot equal positive 2. So they say all real x's other than x equal plus or minus 2. I say it, all real numbers as long as x is not equal to plus or minus 2. It says the same thing. It's just other than is their negation. I say not equal to. There's my negation. Those two values are excluded from the domain because the division by 0 is undefined. Now, if you were to represent that domain, the real number line is a set of all real numbers. So it would be like this. I can't draw straight lines. Okay. Going to positive infinity from negative infinity. Going in both directions. Let's just set 0 here. And minus 1 plus 1 plus 2 minus 2. Let's just draw circles here at plus and minus 2. All real numbers. Whoa, where did it go? Okay. All real numbers here. Any real number here. Any real number in between here. And any real number here. That's all in the domain. The only two places that are not in the domain are at these two values, x equal negative 2 and x equal plus 2. All other numbers are good. Negative 1.999999999 is perfectly fine. Positive 2.000000001, that's perfectly fine. But 2.0, not fine, okay? And, negative 2.000, not fine. Those two cannot be in there. Everything else, no matter how close you get to negative 2, if I can get my pen back, where are you, pen? There you are. Okay, you can get as close as you want to the negative 2 on either side, and to positive 2, okay, on either side. But you can't hit plus or minus 2. Those are forbidden. Okay, so there's a case of an implied domain. And here's PC coming in. And let me see, it seems like I do remember there was a PC before, but I don't remember who it is. Who is it? Who is PC coming in the class? Just come in. Who is it? Shamari. Okay. Now I'm still really concerned. I got a message that Shay Newell was waiting to come in, but I was on an email at the time, so I couldn't open the class, and now Shay's not here. Has anyone heard from Shay? So I don't know what's going on there. All right, but welcome to the class. Okay. Now, we're talking about domain of a function, and these are implied domains anytime you have values like here where you have to restrict your values for x. And here the only two restrictions, x can't be negative 2 or positive 2, because both of those would make your denominator 0, and we can never ever divide by 0. Okay, any questions on that? All right, I can't advance. There we go. Another common implied domain is that used to avoid even roots of negative numbers. Okay, so for instance, if f of x is equal to the square root of x, again we assume all real numbers unless we have to exclude some. Are there any numbers that you can't take the square root of? You cannot take the square root of negative numbers. You can take the square root of 0, but you can't take the square root of negative numbers. So here again, your implied domain would be all the x's, because it's all that's in there, greater than or equal to 0. Now this is how we say it in math speak. It's a lot more concise. You don't have to say x can't be a negative number. That takes too much to write. All you have to write is this: x greater than or equal to 0. That means it's greater than 0 or equal 0, never less than 0. Always greater than or equal to 0. That's the shorthand for writing it. Now, they do give you a hint of a couple ways to write this. You can say it just like this: x has to be greater than or equal to 0. In fact, if I were writing this down, I would probably put it right here: x greater than or equal to 0. That says it all. F of x is the square root of x as long as x is positive or non-negative. That's the better way. Another way to express it that they don't mention is set notation. In the old days they used to use this a lot, and that would be the set of all x's. This will be the domain of this function f. This is a shorthand for me too. Set of all x's such that, the vertical lines mean such that, x is greater than or equal to 0. Now, all you do is put the same phrase here in set notation. The braces mean it's a set, and that's how you read that. Not necessary, but you could do it that way. Or, this is called interval notation. Interval notation, this says 0 is included. That's the square bracket. That means there is an equal sign here, and it goes all the way to positive infinity. Now, positive infinity is not a number, so therefore that's always followed by or preceded, if it's a negative infinity, by parentheses. So let's go back to the last one. Okay, in fact, I'll screen back there. Here's another way to express this. In set notation, it would be the domain of this f would be the set of all real numbers x such that, and just like we said down here, x is not equal, or how I said it, not equal to plus or minus 2. That says it all. Okay? You see, you can't really put theirs in here that way because you'd say it's equal to that, but say it's not equal. Or in interval notation, now this for interval notation is a little more awkward. Remember up here, this goes all the way to negative infinity, so it starts at negative infinity, always precede or follow an infinity by parentheses, up to the number negative 2. But since negative 2 cannot be included, whoops, here comes Shay. She's finally here. Good deal. Okay. Let me get her marked here. Shay, it's good to have you. I was doing emails and I saw that you were waiting to come in the class, but I was in the middle of an email and I couldn't let you in. And then when I opened the class, I couldn't find you. Okay, so glad you made it. Okay. So I was just showing how we can express this in interval notation. This is the first part. This is the part over here. And why in the world? Oh, there it is. This is the part here. Okay. From negative infinity, my pen's not writing. Oh, there it is. Okay. From negative infinity to minus 2, but not including minus 2. And then we use the symbol union that with, pick up just past negative 2, but don't include negative 2. So another parentheses there, negative 2, and you go all the way to positive 2. But don't include positive 2 because that's not included either. Union that with this part over here, and that picks up at positive 2 but does not include it. That's why we use parentheses, and that goes all the way to infinity. So this is how we would express this result, the domain of this function, in interval notation. That's a little long and awkward. Much easier to write it this way. Okay? Or just say this. X cannot equal plus or minus 2. To me, that says it all. Okay? Now, this one back here that we were just looking at, this can include 0, so your interval notation does include 0. Notice it doesn't include anything negative. Starting at 0, including 0, and going all the way to positive infinity. So this is the interval notation. In this case, this is a simpler form. This takes a little more room to write, but frankly, this says it all. So I see no reason not to just say that. Okay? But the book uses interval notation a lot. Every now and then we'll revert to set notation, so that's why I wanted you to see them all. In general, the domain of a function excludes values that would cause either division by 0 or that result in trying to take a square root of or an even root of a negative number. Now, just for your information, if this had been a cube root here, you can take the cube root of anything. This would be all real numbers. You wouldn't put anything there. Your domain would be in set notation. If you wanted to put it, the set of all x's such that you could just write it this way. X is an element of the real number system. That means real numbers. Another way to write it is minus infinity to positive infinity. Everything in between. That would be interval notation. Or you could write that in here, minus infinity less than x less than positive infinity. Notice we never put equal to because infinity is not a number, so x won't ever be that. It just goes all up, all real numbers. You could just say that. That is if it's an odd root, a third root, a fifth root, a seventh root, any odd root. If this was a fourth root or a sixth root or an eighth root, any even root, then you're this. It can't be, it has to be greater than or equal to 0. So even roots have restrictions, odd roots have no restrictions. Okay. Any questions on that? Anything we've done so far? Domain of a function. Any questions? Okay. Let's move on. Here we'll do find the domain of each of these functions. Now that first is a set of ordered pairs. So what would be its domain? It would be a set of the input values, which are the numbers that show up first. So that would be the set of -3, -1, 0, 2, and 4. That is an explicit domain. There it is. That's all you got. Oh, here's Shay came back. So maybe Shay was having trouble before, and that's why she got out and came back. Okay. Welcome back, Shay. I hope you're here. Any questions on A? Okay, I want you to tell me if there are any issues with G. Anybody? What can X not be? There's Shay. I see you're in here now. I saw that you were waiting earlier, but I was on doing emails and I couldn't get you in. And then later I couldn't get you in. Okay, but glad you made it.
I'm sorry, it was my phone.
Okay, that happens. In fact, my wife was in a meeting yesterday and she kept getting bumped out. And it's just, I think this global wireless system, internet system, everything is being stretched to the limit. It's hard to get good signals. I had a student yesterday who said that I was coming through garbled and he was coming through garbled. And my wife told me this morning, you should have told him to turn off his video because sometimes that limits your bandwidth. We're supposed to have a Spectrum service that gives us really good bandwidth. Yesterday when she was having problems, we were getting 3 and 4 where we're supposed to get close to 100 or more. Okay, so yeah. And it's just their system, it was just stretched to the limit. This morning we were at 90 something, but no one's on it yet. All right, tell me if there are any limitations for G, the domain of G. Anyone got any ideas? Well, here you see a denominator. What can denominators never be? 0. So write that down. X plus 5 cannot equal 0. Then subtract 5 from both sides. These go away and you get X cannot equal -5. Everything else X could do. -5, no it can't. Now this is an infinite set, so you can't list it like we did here. That's a discrete set up here. This is an infinite set down here, a continuous set. So you could either do in set notation the set of all x's such that x is not equal to -5. Or like I like to do is just put a comma here and say x cannot equal -5. All other x's are good. In interval notation, this would be, because all x's are good, from -infinity all the way to -5. You have to stop there, not include -5, union that with, pick up again with -5. That's a parentheses there, and go all the way to positive infinity. Okay, that's how you put it in interval notation. This is set notation here. This is just simply writing it can't be that, and this is interval notation. All right, the next one, C. That's a little on the tricky side. Okay, the volume of a sphere, what would be the domain of that function? The volume of a sphere is V is equal to 4/3 pi r cubed. Now you don't have to know that, but if you did want to find it out, go to the back inside cover of your book and you'll see the volume of a sphere is given there. This is the back inside cover of the book. I don't know if you can read that. 4/3 pi r cubed. That's the volume of a sphere. Now, are there any limitations? In the first place, what's your independent variable? What is your dependent variable? We got to determine that first. What is your input? What's your output? Any guesses? Y'all are so talkative today. It must be Thursday. Well, obviously the input has to be, I'm not even writing and it's doing that. Input has to be the radius. The output is the volume. Okay? So this is what we're interested in, the domain. So are there any limitations on the radius of a sphere? Can you think of any? Number one, it's not in the denominator. No problems there. Not in an even root, square root or fourth root or anything like that. No problem there. But if they just put this formula down here, you'd say all real numbers. But they told you what this was, the volume of a sphere. Now, everybody knows what a sphere is, right? A ball, a basketball, a tennis ball, ping pong ball, a ball, a spherical shape. The Earth's a sort of spherical shape, okay? Now, are there any limitations on what the radius of that sphere could be? Has to be positive. Have you ever bounced a basketball that had a negative radius? That makes no sense. Have you ever hit a ball that had 0 radius? Sure, I just smacked one. No, it's not a ball. It's not a sphere unless it has a radius. A positive radius, okay? So therefore, your domain here is R has to be greater than 0. Not equal 0. Here, Kanisha must have had to, well, I can't do there. Had to go out and come back in. So I already had her here. Yeah. Okay. So just from a physical point of view, R has to be positive. It can't be negative. It can't be 0. Okay? So in set notation, that would be the set of all radii such that R is greater than 0. Now, in reality, you can't have an infinite sphere either, okay? But there's no upper limit that I know of, so you just have to put it that way. In interval notation, anyone want to hazard a guess what that would be? It can't be 0, but it can be anything close to 0. So that would be the interval, not counting 0, but starting at 0, not counting 0, all the way up to positive infinity. Now, in reality, you can't have an infinite sphere, but I don't know what the number is, so we'll just put that. All right, any questions on that one? How about number D? I can't get my pen. There it is, somewhere there. There's the pen. Okay. Any limitations here? Well, I had a pen and now I can't find it. Where is my, there it is. Okay. Any limitations here? Now this is one like B, which had a algebraic limitation. So does this one. This one was just a finite set, This one, a physical limitation. Your radius has to be greater than 0, positive radius. Here we're back to algebraic. What has to be true about whatever's under a radical? even radical. What did we say before? You can't. Say again? No, it can be 0. Can't be negative. So let's write down what you just said. 4 minus 3x. Now, I don't want to spell out can't be negative, so I'll write that as greater than or equal to, because it can be 0. It just can't be a negative number, like you said. So what do? We want to solve for x, but this is an inequality now. So we'll subtract 4 from both sides, just like we do with an equation. These go to 0, so you get minus 3x is greater than or equal to negative 4. Right? But we want to solve for x. So what do? Divide both sides by negative 3. Okay? Now, I don't know if you remember your rules for inequalities. If you add or subtract any number from either side, from both sides of an inequality, a positive number, negative number, whatever, it doesn't change the direction of the inequality. This is what I call a directional inequality. Doesn't change the direction. If you multiply or divide by a positive number, it doesn't change the direction of the inequality. However, if you multiply or divide by a negative number, you flip the inequality. So this becomes, these go out, and you get x is less than or equal to 4/3. That's what your domain for this one is. It's a little trickier, and if I were doing this, I would just write this here. X is less than or equal to 4/3.
What is the sign flip?
What's what?
What is the sign flip the less than?
Okay, I still couldn't hear you.
What is the sign flip the less than when it was greater?
Okay, this one down here, this is greater than or equal to. This right here is greater than or equal to. This means less than or equal to. Is that what you ask?
Yes.
Okay. Okay, can you tell the difference? Greater than, I think of it this way. The big side is toward the thing that's bigger, okay? The little side, the point, is toward the things that's smaller. If you're doing less than or equal to, then the little thing is on the side that's smaller and the big thing's on the side that's larger, okay? You have to flip them only when you multiply or divide by a negative number, not a positive number, negative number. Adding or subtracting positive or negative doesn't change that at all. Only multiplying or dividing by a negative number. Now, if you had a not equal to, you can do anything you want to, because that's not directional. But this is directional. Okay? Is that answer? Okay. Now,
Yes.
let's do this in set notation. That would be pretty easy, because you basically take exactly what's here and say the set of all x's such that x is less than or equal to 4/3. That's just right what it says. To me, that's even easier. Okay? In interval notation, that means if it's less than, x can be anything less than. That means you're starting way over there at negative infinity, going up to and including 4/3. And because it includes it, we put the bracket. If you have the equal sign with the directional inequality, you put the bracket here. If you have no equal sign here, you put parentheses. Does that make sense? Bracket means you include it. Parentheses means you do not. Okay. Now, I'm sort of a cynic here. And I want to make sure I got it right. Now, these are the values for x's. So I'm going to take that last value there, that 4/3. I'm going to plug it in here. When I multiply 3 times 4/3, the 3's cancel out, and that gives me a 4, but that's a 4 minus 4. That's 0. Yes, I can take that square root. I'm okay there. But let me take something that's less than than 4/3. That's what it says, any x less than 4/3. Now my favorite would be, of course, 0. So if you put a 0 here, that would give you the square root of 4. Yes, you can do that too. Now if you really wanted to push it, you could say, well, let's take something greater than 4/3, like maybe 2. 4/3 is 1 and 1 1/3. So let's take 2. What happens if you put a 2 in here? That would be 4 minus 3 times 2 would be 6. 4 minus 6 would be a negative 2. You cannot take the square root of a negative 2. So yes, that makes it look like that's our correct answer. You don't have to do that. I just do it sometimes to make sure I haven't messed up a sign or something. It works. Any questions on this before we go to how they do it? They sometimes won't do quite as much detail as what I just said. Let's see what they do. The first one, the domain of F is the set of all first coordinates of the set of ordered pairs, because the ordered pairs are xy, 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 xy. So your x's are the first one. Set of -3, -1, 0, 2, and 4. Exactly like we got. That's a explicit domain. There they are, that's all, nothing else. Okay. The next one, you have to exclude any x values that would make your denominator 0. So therefore, the domain of G would be all real numbers x, except that one that made the denominator 0, which would be x equal -5. Now, if you want to write out the whole sentence like that, you can. The math symbols make it a lot shorter, and they say it well. Okay, I would just say x not equal to -5. I don't have to say anything else. Okay. The C, because that function represents a whatever that was, I don't know, a physical entity, the volume of a sphere, the values of the radius must be positive. You can't have a sphere with no radius. That would be empty air. Okay, you can't have a negative radius. I can't even imagine what that would look like. Turn the ball inside out? No, you can't do that. So it has to be positive. So that basically is saying that R has to be greater than 0. The set of all real numbers are such that R is greater than 0. R was your independent variable, so that's what you're dealing with in the domain. Does that make sense? Okay, in D, what was inside the radical has to be positive or non-negative. Cannot be negative, could be 0, could be positive. That's what this says here. Greater than or equal to 0. It could be 0 or anything greater than 0. And then, by magic, they just say, by solving the inequality, you conclude this. They didn't show you how to solve the inequality. They just said you get this. Well, I hope I did it in gory detail. Any x less than or equal to 4/3. Any questions on those? Oh, here comes Janae. She must have had to leave. Maybe that was the sound we heard before, because I already had Janae here, I'm pretty sure, didn't I? Yeah. Okay. Any questions? All right. I can't advance my slide. I don't know why. There we go. So the domain in this interval, now they give the interval notation, is from -infinity, because anything less than this, that goes all the way down to -infinity, so that's not really a number, all the way up to and including 4/3. So you put the square bracket there because you have an equal sign there. Not just a less than, also an equal there, so you put the square bracket there. Does that make sense? Sometimes they put that in, sometimes they don't. But if you put the interval notation, be sure you use the right symbol. Now, example 7c, that's the one about the volume of the sphere. Note that the domain of the function may be implied by its physical context. Okay? So this function by itself, if they didn't say that's the volume of a sphere, you'd say all real numbers. Okay? No reason to restrict R if you didn't know that was the volume of the sphere. If that was just an equation, y is equal to 4/3 pi x squared, if you didn't know that was the volume of a sphere, then no restrictions whatsoever. Okay, but because it was a physical, they told you this is the volume of a sphere. That implies the sphere cannot have a negative radius or even a 0 radius. Okay, we beat that to death, I think. All right, that was example 7. We're now moving to applications. Okay. Now, you work in the marketing department of a soft drink company, and you're experimenting with a new can for iced tea that is slightly narrower and taller than the standard can. For your experimental can, now here's a statement. The ratio of the height to the radius is 4. Now we need to take that phrase there, that clause there, and write it as a mathematical sentence. I call this translating. What do we mean by ratio? Anyone know? Ratio is comparing of two numbers in a division sense. Ratio. And so when we say the ratio of the height, that would be h to the radius divided by r, that's what ratio of height to radius is, translates as equal sign 4. I took this sentence here, ratio of height to radius, where's my pen? There it is 4. The ratio of height to radius, h over r, translates as equal, 4 is 4. And that's exactly what they've written here. They just sort of snuck it in there. Okay, that's important to this problem. Now, the A part says, write the volume of the can as a function of the radius r. Okay, now here's a can. Now they show you here, this iced tea can is circular. Okay, that's an assumption here that it's a right circular cylinder. And the volume of a right circular cylinder, and I don't think this one's in the back, let me check. Yes it is, yes it is, okay? It's in the back of your book, but I'll tell you how to get it, okay? I'll show you that in a minute, okay? The volume, most of the time on regular shapes like this, where in the world did my pen go? There it is, okay? Volume is equal to the area of the base, that's why I make it a capital B, times the height. Well, what is the area of this base? What did I say this shape was here? The base or the top, either one, those are circles. What's the area of a circle? Pi r squared. See, that's the dimension here, radius, pi r squared times the height. There's the volume of this can. The trouble is they want that written as a function of radius alone, not of height. See, this has two variables in it, radius and height. But we know that the height and radius are linked, you might say, by this statement here. So we want to get rid of the h and have only r. So let's take this equation here, multiply both sides by r, sorry, it's supposed to be r, and that way the r's will cancel out here, and now you have h is equal to 4r. So you take that and put it here. V is equal to pi r squared, that's in terms of h, but now the h in terms of r is times 4r. Okay, now if you join all the constants together, 4 and pi are both constant. Pi is a number, remember, 3.141 pi, blah, 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 blah. It's an irrational number, but it's a number. So put those in front, 4 pi, and then put all your variables together, r squared times r is r cubed. There is the volume of the can as a function of radius alone. There you have it. Now, the second one said, write the same volume of the can as a function of height alone. Well, now we don't want radius in the picture. This picture right here, going back to, goodness, I can't find my pen. There it is. We don't want r here, we want h. So therefore, let's take this equation we just came up with and solve for r. So to do that, we divide both sides by 4. Okay, and that wipes out this, and this gives us r is equal to h over 4. Now we take this and put it in here instead of r, and you get v is equal to pi, and this r we put h over 4, but we're going to square that and then multiply it by h, and that's h is fine because we want it in terms of h. So we take that one, and that will be pi, and we square h, you get h squared. Square 4, you get 16, and multiply it by h. Now let's get all the constants together. Pi 16ths times h cubed. H squared, where is it? There it is. H squared times h is h cubed. So there's your volume as a function of height alone. Sorry about that. Okay, we should have 22 students here. Let me just check and make sure we got everybody. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Perfect. Way to go, team. Good attendance today. All right. And I guess I forgot to tell you the good news, bad news situation. I'll come back to the problem in a minute, but I just remembered this. Y'all know the good news, bad news coming up? Let me give you the bad news first. Monday's a holiday. Oh, boo hiss. I can hear you booing in the background. It's Labor Day. No school. The college is closed. Of course, we're closed anyway. No one will be here. I won't be here. Nothing. Okay. That's the bad news. Here's the good news. Doesn't affect us any because we meet on Tuesday and Thursday. So we won't miss a class. That's the good news. But you will miss your Monday and Wednesday classes. Your Monday classes. That's the bad news. All right. That's aside. Any questions on what I did here? You want to see how they did it? I think it was pretty similar.
You are recording this, correct, Mr. Fowler?
Yes, I am. I don't think you can see it, but here in the corner is a little red circle with 2 bars by it, and it's counting up. It's been recording about 48 minutes. But thank you for asking, okay? Because sometimes I forget. And also at the end of class, right before we leave, someone asked me, have you stopped the recorder? Maybe I have, maybe I haven't, but I always need the help. The old gray cells ain't what they used to be. Okay. Any other questions? Good question. Let's go on and see how they did the problem. Well, they started with, and I meant to show you this in the book. Not everything you'll need is back here, but a lot of them will be. Back inside cover of the book, there's a right circular cylinder. That's your iced tea can. And there's the volume is equal to, I can't read it, is pi r squared h, where r is the radius of the circular top and bottom, h is the height of the lateral side. Oh, this book is heavy. Okay. All right. So there's your formula. You could either get it from the back of the book, or if you knew it already, base times height, and that's the area of the base is pi r squared. Okay. Because they left off the part here of that ratio that we knew, h over r is equal to 4, that we got from translation, multiply both sides of that equation by r, and you get h is equal to 4r. So since you want this as a function of r alone, get the h's out of there by putting 4r instead, because h is equal to 4r. And then all you do is gather your numbers together for pi, and gather your variables together, r cubed. There you have the function volume as a function of r alone. This time we start with that same combined volume. That's a correct answer, but this is not a function of h alone. You still got r's in there. So we take this one that we had, h is equal to 4r, and solve for r. That means divide both sides by 4. Okay, you get r is equal to h over 4. So now we put that in instead of our r's. H over 4 squared, because your r was squared, h over 4 is squared. And I think they just do it in one step. I showed you 2 steps. That gives you pi h cubed over 16. Now, this brings up another issue. If you remember how I wrote my answer, it was like this. I gathered the numbers together and said pi 16th times h cubed. This and this are exactly equivalent. No difference there at all. It's just how you write it. However, if you're doing WebAssign and it's out there available for you, and I had some questions about this, I think it was from a different class, or maybe it was from this class, I don't recall. One of my classes, I believe it was another class. Well, okay, what about the problems in WebAssign? I said, hey, I told you this before, the guy hadn't been here before. I said, hey, the problems in WebAssign are out there only if you want to use them. It's only for your benefit. I've tried using WebAssign before, and I wind up calming students down because WebAssign would have told them this is a wrong answer. Because WebAssign is a programmed computer situation. Whoever programmed it said that's the answer and that's the only right answer. This is perfectly correct, nothing wrong with it, but because it doesn't look like this, WebAssign would say incorrect, do it again, or you get a 0 or whatever. And that freaks students out. They think, what am I doing wrong? You did nothing wrong. You got exactly the right answer. It's just a computer program was looking for one and only one answer. You gave them a different formula for that answer. It said you were wrong. You weren't. It's just a different form. So rather than having to deal with that repeatedly, more often I'm dealing with that than I was ever dealing with, oh, well, you made a mistake. Here's how that came out. Most of the time it was, no, you did it absolutely right. Don't sweat it. Okay? Just like I say with Blackboard. They're putting all sorts of things out there, giving you zeros or doing things. I didn't do that. Whoever set up these, I'm sorry to say this, these stupid shells that we have to use, that's doing that. As soon as I can get out there, and I've been trying to print off everything that's been turned in. I've got this many to grade of the things I've printed off. I'm hoping to get a lot of these done tomorrow. I've still got more to print, so I'll be printing tonight. If I can finish printing tonight, then I'll start grading tonight. But then I've got 4 hours tomorrow. I'll try to do that. I'm taking with me. We'll be out of town this weekend. My wife's parents wanted to go to the place on Smith Lake, where we'll be isolated, and they've been stuck in their house for weeks on end, and so we're going to go up there, and they're in their upper 80s. They're celebrating, or they celebrated this week, day before yesterday, their 65th wedding anniversary. I'm never gonna make 65 years. We were married way too late for that. Okay, but I would have been would have to live to 100 to celebrate that. Don't think I'm going to make it. My wife would have to live to be 93. So don't think that's going to happen. But they're celebrating their anniversary, so we're meeting with them up there at Smith Lake. So I'll be away from internet, away from email. We have internet, but it's really, really, really weak. So I may be able to, but we don't have a printer up there. So I can't print off anything. So I'm taking the papers. I'll be grading papers Anytime I'm not mowing the yard, picking up sticks, killing poison, sweeping off leaves, there's plenty to do up there. But anytime I've got free time, I'll be grading. I'll be trying to catch up. But I won't be able to catch up Blackboard unless I can get a strong enough internet signal to do so. And with everybody up there on their cell phones, the odds are I won't be able to do that. So, in fact, they all can't get on the cell phone at the same time. So, it's that lousy of a signal. So, I won't be available this weekend, but I will be trying to grade papers. So, if you see things, you've turned something in, I'll try to get them printed this evening and tomorrow morning, and then over the weekend, hopefully get them graded and are acknowledged, and then if I can, I'll put them on Blackboard, but otherwise it'll be sometime next week. I don't know what time we're coming back Monday. I may have time Monday evening to do it once we get back home. But finally, hopefully next week, I'll be able to catch up the grading. So, any questions? That has nothing to do with math, but just to let you know. All right.
I have a question again,
Yes.
Mr. Fowler.
What is that?
You have another class at 10, but right after this class, do you mind if I speak with you for about two or 3 minutes?
Don't mind at all. Do you want it after everybody leaves or?
Yeah, I mean, just after we get done with all the class business.
Right. Okay. And do you mind if other people are listening in?
I don't care at all.
Okay, good. Okay, well, yeah, just let me know. In fact, we might even be able to end a few minutes early if we need to. If it's a question to do with math, we can do it right now. Is it?
No.
Okay, well, we can do it now anyway, but let's go on and try to finish this section. All right, but thanks for mentioning that. No problem at all. Okay, so that's example 8. Let's move. Oh, they're skipping example 9. I kind of in favor of skipping it myself, but I think we need to do it because it's one that you might see one similar to it again. Here's the whiteboard. Again, with the whiteboard, I've got to do some maneuvering. You can't see it, but they put this toolbar right in the whiteboard, so I can't write. And then they position the whiteboard. All you see is white, I think, but I have a limited space I can write, so I'm going to maximize my whiteboard. Okay, I hope that's not anyone coming in, is it? I don't think so. Nope, got everybody here. Okay, here's example 9. A batter hits a baseball at a point 3 feet above the ground, and I wish I could draw a decent picture, but if you picture that, 3 feet above the ground is about waist high. Waist high would be a sweet part of the swing, so that's right about where you want to hit it, about 3 feet above the ground at a velocity of 100 feet per second. I'm not sure I can hit one that fast, but this batter can, at an angle of 45 degrees. So let me get as much of that as I can in here. Okay, here is my ugly picture of the batter, and he's got the bat in his hand somewhere here. He's got a helmet on, I guess. Okay, being safe. He swings the bat and hits the ball right about waist high, so that's 3 feet above the ground. And the ball takes off with a velocity of 100 feet per second. That's its velocity. Okay, the angle here, I didn't draw that too well. The angle here is 45 degrees. Now, that doesn't look like a 45-degree angle, but my drawing is terrible. Okay, that just gives you a picture of what's happening. Here's the path of the baseball here, and this is supposed to be the horizontal here. Okay, so maybe that would be better. Okay, now the path of the baseball is given by this function. F of x is equal to negative 0.0032 x squared plus x plus 3. Weird function, huh? Well, what do these things mean? This F here, that is the height of the baseball. So I would have called that H. That's the height. The height of the ball at any time, at any position. Sorry. The X here is the horizontal. So this is the vertical movement. There's the horizontal distance from home plate. So this would be, if the ball's right here, this would be the X this way, and the height would be this way. This would be your f of x. For this x, right here, this would be the ball up here. Okay, so this is the horizontal distance. I can't write. This pen doesn't do too well with writing. That's your x from home plate. Okay, in feet. Now the question is, somewhere out here, way out here, here you have a fence. Okay, and this fence is 10 feet tall. Now obviously mine's not drawn to scale, but let's just imagine that's 10 feet tall here. That distance here from here to the fence is 300 feet. Okay? The question is, will the baseball clear the 10-foot fence located 300 feet from the home plate? Well, again, this is your height. This is your f of x here. This is your x. That's your horizontal distance from home plate. So to answer the question, what we do is plug in 300. F of 300. When the ball's 300 feet away, will it have enough height to clear the fence? Well, that's negative 0.0032 times 300 feet squared. Wow. Okay. Plus, now I'm going to leave off the units. Okay. There's a reason for that. Okay. Plus 300 plus 3. Okay. Now, I'll tell you a little bit of what the deal is here. The negative sign means gravity is pulling that ball downward. Okay, it started 3 feet above the ground because that's where he hit it. So when x was equal to 0, it's 3 feet off the ground. So that's good. That's right where he hit the ball, 3 feet off the ground. Okay, now if the ball were traveling a 45-degree angle, would give you the same y as it would the x, because if I drew that angle right, 45 degrees is exactly halfway. So whatever your y is here, that's the same as your x here. So that would travel, if it was going without gravity, it would have gone 300 feet high, plus the 3 feet where you hit it. But gravity is pulling it downward. Okay, so that's why the minus sign is here, and it's pulling downward like this. So let's see who wins. Gravity pulling down, the ball trying to make its way up. Well, let's plug and see. This will be minus 0.0032, and when you square 300, you get 9 with 4 zeros after it. You double your number of zeros. You square this number here, double the number of zeros, plus 300 plus 3. I just should make that 303. Okay, now I'm going to pull out my handy dandy calculator. I could do that in my head, but I don't feel like it. It's a Thursday late in the week. I'm too tired to do that. So let's pull out. My phone got fully charged anyway, so let's use it. Pull out my calculator. Okay, and I'm going to do 0.0032 times 90,000 equal, that's 288, but there's a minus sign in front of it, so I'm going to make that minus 288 and add to that my 303. 303. 300 plus 3 is 303. And what you get? I get 15 feet. Yes, that ball clears the fence by 5 feet to spare. Not even a good center fielder pushing off the wall and everything else, his glove up there, he's not going to get 15 feet up. So yes, it clears the fence. That guy got a home run, unless that was in foul territory. So we don't know. So the answer is yes, it does. It makes it 15 feet up by that point. Gravity's pulling it downward, but it made it across the fence. And I haven't mentioned this today. I think I mentioned it early. Every one of these examples has a checkpoint after it. Those checkpoints are very important for you to do as soon as you can outside of class. Okay? As soon as you can after class. If you have another class coming up, wait until that one's over. As soon as you can, try to do the checkpoints and then move on from there. Now, there's another example in the book, and this one's rather tedious, so I may not do it. This is example 10. How are we doing on? Oh man, we've run out of time again. Look at this. I thought for sure we were going to finish this section today. So we'll begin next time, and we probably won't do the whole problem, but we'll do part of it. We'll start with example 10, and we should finish this section next time. Okay? We'll start there next time. Homework exercises here would be any of the odds, 5 or 7. They're both at Calc Chat. 7's at Calc View. Number 9's at Calc Chat. Any of the odds 11 through 17, they're all at Calc Chat. 11's at Calc View. Any of the odds 19 to 29, they're all at Calc Chat. 21's at Calc View. Any of the odds either 31 or 33, both at Calc Chat. Any of the odds 35 to 41, they're all at Calc Chat. 37's at Calc View. 43 or 45, they're both at Calc Chat. 43's at Calc View. 47 or 40, oh I'm sorry, any of the odds 47 through 55, they're all at Calc Chat. 49's at Calc View. 57 or, well, I'd say any of the odds 57 through as many of these as you can. 57 through 71. Okay, you may not be able to do them all, but do any of those that you feel comfortable doing. When we do that last exercise, that will probably enable you to do them all. Okay, so let me turn off my calculator here. Yes, yes. Okay. Okay, can't you do what? I missed the last part.
Didn't you say we could go back and do the work?
Oh, absolutely. Yes. If you haven't had a book or couldn't get your thing, yeah, you can go back and just send me, when you send it to me, either through through Blackboard message or through an email. When you send it to me, just put on there. Be sure you put your name. I try to always catch it if you don't, but put your name if you can. Also say which week it's representing. I only need one problem a week, but send me any problems, even if it's more than one, that you may be having trouble with. Yeah, you can send those. I will mark them that way. So even if that stupid Blackboard thing says that it's past due, no point, I'll override that. If I can't figure out override it, I'll take it out and I'll put my own thing in there. So don't sweat that. Just get me the work. That's the important thing. Good question. Okay. And Janae, you had a question. You want me to keep the recorder on or turn it off?
Turn it off.
Okay. I'm going to turn off the recorder now. Anyone else have a math question before I turn off the recorder? Okay. So